Let's talk about line equations. When you have an equation of the form y equals to mx plus b, this will give a line in the two-dimensional plane. And this specific form is called Slope Intercept Form because m is called the slope and b is called the y-intercept. Now let me explain why these have these names. So if you have something like y equals to 2x plus 1, so in this case m would be 2 and b would be 1, and y equals to mx plus b, right? First, if you plug in 0, you get 1, so you get the value of b. You get 1. If you plug in 0, you get 1, and that's exactly on the y-axis, so that's why this is called the y-intercept. Also, if you have the slope, you can represent this as a fraction, and you interpret it as rise over 1. And what it means is that you go up by 2 because rise is 2, and the run is 1, so you go right, you run right by 1, and that's your next point. So if you plug in 1, it's 1 comma 3, right? So this point 1 comma 3 is actually 2 steps up and 1 step right from the 1. And connecting these points actually gives you the graph of the entire line. So if you're to actually plot more points and slowly come up with a table, eventually you're going to get this line. Okay, so this is the graph of y equals to 2x plus 1. So let's look at a problem. Find the equation of line passing 2 comma 3 and 5 negative 1. So we're going to find the slope first. So we're trying to find the equation in the form of y equals to mx plus b. So that means we have to find the value of the slope. We also have to find the value of b. And the slope, although I just wrote it down as rise over run, the more formal way of calling rise is change of y, because change of the y coordinates is the change of y. And run is actually also known as the change of x. So this is the formula for finding m, and you have to look at the y values to think about the change of y. So what is the change of y? Y went from 3 to negative 1. So it decreased, right? It decreased. It went from 3 to negative 1. It decreased. And if you want to know how much it's decreasing, what's the change as it's decreasing, you always compute by computing final value minus initial value. So the final value of y is negative 1, and you subtract the initial value 3, and you get negative 4, right? That's your change of y. Now see that you have a negative sign. That means y decreased, as we have observed. From 3 to negative 1 is decreasing, right? So change of y is negative 4. In the same way, x went from 2 to 5, right? So 2 to 5. So that means change of x is final value 5 minus initial value 2, which is 3. Now the slope m is therefore change of y. We just found out that it's negative 4, and change of x is 3, so that's equal to negative 4/3. Alright, So we found the m value. Now we have to find the value of b. So you may think of this part as like step 1. You find value of m this way, and we now know that m is negative 4/3, and we don't know what value of b is. Then you think about the condition that 2, 3 should be a point on this line. What's important is that for a point to be on the graph of any equation, it means that when you plug in these values, you should get the equal to hold up. So you can say that since 2, 3 is on this line, y equals to negative 4/3 x plus b, you can set this value should be x, and 3 is the value for y. So 3 is equal to negative 4/3 times 2 plus b. And when you multiply a number to a fraction, 4/3 times 2, you can think of 2 as 2 over 1, and multiplication is done by top to top, bottom to bottom, so you end up with 8 over 3. Okay, so now we can just proceed to find b by solving this equation. So we can do 3 equals to negative 8 over 3 plus b, and then you can move this to the other side to get b equals to 3 plus 8 over 3. See, minus, when you move it to the other side, it becomes plus, right? And now that we have a number plus a fraction, we need common denominators, with 3 being the common denominator. So we can rewrite 3 as 9 divided by 3 is 3, right? So we can rewrite 3 as 9 over 3. And if you have common denominators, now you can just add the top. So addition of fractions requires 2 steps. First, you need common denominators, and once you have common denominators, the common denominator is just written once, and you just add the top. So that's value of b. And finally, the answer to the question is that you have y equals to negative 4/3 x plus 17 over 3. Now there is another way of doing this, which is equally as important, because later in calculus you need to use this other form, which is called the point slope form. So let me write that first. Point slope form. And the form is y minus y1 equals to m x minus x1. And you need to know what x1 and y1 and m means. So x1 comma y1 is any point of the line. So if you know any point of the line, you can use that for x1, y1. And m is the slope. Now in our case, let's just say we know that m is negative 4/3 already, and we want to know if we want to know the line equation that passes through 2, 3. So this second alternative method uses 2 as x1 and 3 as y1, and uses this formula, and you get y minus 3 equals to negative 4/3 x minus 2. And you can, if you expand this and simplify, negative times negative is positive, 2 times 4 is 8, and then if you add 3 both sides, you will see that at the end of the day it gives you the same answer as before. 3 plus 8 over 3, we just did it. It ends up being 17 over 3, right? So you do get the same exact answer by using this point slope form. Now, let me just make another comment why this actually works. See, first we have to verify that this does pass 2, 3. And as I said before, if I plug in 2 into x and 3 into y, if indeed 2, 3 is on this graph, it must satisfy the equation, right? But if once you plug in the values, you immediately notice that 3 minus 3 is 0, and 2 minus 2 is 0. So you get 0 for both left and right, so equation does hold. So before we weren't sure if the equation did hold, but after we plug in, we see that 0 is equal to 0, so equation does hold. And that's how you can verify that this equation we just wrote down does pass through 2, 3. Another thing is, if you expand this, eventually this number in front will take place in front of x. It just becomes the coefficient of x, right? So it does give you it does become the slope in the in the slope intercept form. Okay, so if you turn this point slope form into slope intercept form, then you do see that this m and this m has to be equal, because if you multiply, you get mx, right? So that's another way to see that indeed the picture, the equation that you're going to get at the end of the day will have the slope that you want, and it'll also satisfy the point will satisfy the equation, which means it will also pass through 2, 3. And that's why the point slope form works. Now let's talk about perpendicular slopes. If you have y equals to mx, that gives you a line passing through 0 because it's plus 0. The y-intercept is 0. So it passes through 0, and the slope is m. And what I want to do with this is just think about this being x, this being y, this being, well, that would be the negative of x, and this side will be negative of y. And my plan is to build another line that's perpendicular to this by rotating these axes. Okay, if I rotate this 90 degrees, then the entire graph will rotate, giving you this. This will also rotate, and it will become this one, right? So what does that mean? That means if you have y equals to mx, rotate 90 degrees counterclockwise, then x goes to y, right? So in here, m and x is replaced by y. And then where does y go? Y goes to negative x. So y gets replaced by negative x. And if you want to solve for y, you solve for y by dividing both sides by m. And the result is negative 1 over m times x equals to m, equals to y. And the claim is that if you indeed do this, you are going to get a line that's perpendicular to your previous line. So we had this line, right? This one would be 90 degrees to the previous line. And this exercise actually tells us a very important property, that the slope perpendicular to slope m is negative 1 over m. In other words, negative reciprocal. Negative reciprocal ends up giving you a line that's perpendicular. Okay, so let's do an example using this. Suppose find equation of line perpendicular to y equals to 2x plus 1, and passes 2 comma negative 3. Okay, and so let's try this. First, slope of y equals to 2x plus 1. This is the slope intercept form, and we learned that the coefficient of x is the slope. So we know that slope is 2. And then, therefore, the perpendicular slope is the negative reciprocal. So you take 1 over 2 and put a minus in front. Okay, so that's the perpendicular slope. Now we do y minus. So we have the slope. We need this. We needed the slope and a point, and if we have a slope and a point, then we can use the point slope form. So let's use the point slope form again. Y minus y1 equals to mx minus x1, where the slope we want is now this. That's the perpendicular slope, and it has to pass through 2 and negative 3. So we do y minus negative 3. This is x1 and that's y1. y1 is negative 3 equals to negative 1/2 x minus 2. Then this is y plus 3. If I multiply this out, this is negative 1/2 x. 2 and 2 cancels, and negative becomes positive, so you end up with positive 1. Subtract 3 both sides, and you get y equals to negative 1/2 x. 1 minus 3 is negative 2. So that's the answer. That's the line that's perpendicular to y equals to 2x plus 1 while passing 2 comma negative 3.